Hi, let's take a look at this question. So, part one, find the length of AB. There's two ways to do this, and I'm going to talk about both. First method is to do a little sketch of the coordinates, and we've got 6, 1, which is about here. Maybe I'll call it 6, 1, and I might as well call it A. Then I've got minus 2, 7. So actually that's going to be up higher, up here. And, you don't always know if you do it quickly, but yeah, I need to maybe move this down. Now we'll ask for the length of AB, so that is this length here. And what I can do is construct a right angle triangle from this slope. So now I've got a right angle, and I can just look at the triangle and figure out the lengths. So I'm going from minus 2 to 6. That means this bottom length is 8. And I'm going from 7 down to 1. So I'm going down, but the actual length is going to be 6. And then if I want to work out the length, I can just use Pythagoras' theorem. 6 squared plus 8 squared square rooted, which is going to be 36 plus 64, which is 100, root 100, or 10. And that's the answer. Second method, and you might prefer this, it's the same idea, is to use a more general formula. So if I called this coordinate x2, y2, and this one here x1, y1, then actually what I'm doing is finding the difference in the x's. I actually just looked at minus 2 and 6 and got 8, but I'm actually done 6 minus minus 2. And in general, it's going to be x2 minus x1. You could even do x1 minus x2. It doesn't matter because you're then squaring it. So whether it's positive or negative doesn't make a difference. And then we do exactly the same for the y's, the differences in the y's, and then squared. So, if you prefer, this is a formula that you can use. Part 2, diagram method. Well, I can see actually that the rise is minus 6 and the run is 8. And therefore, I just get minus 3 over 4. And that's my answer. Let me actually just make it clear that these are my answers. Second method is to use the general formula y2 minus y1 over x2 minus x1. Again, this is just an implementation of rise over run. The rise is the differences in the y's, and the run is the differences in the x. Just make sure you do it the right way around. You could even do y1 minus y2 over x1 minus x2. Just be consistent. But if you substitute the numbers in again, you'll get minus 3 over 4. Finally, we're asked to determine whether this line 4x minus 3y minus 10 equals 0 is perpendicular to AB. So we need to work out the gradient. And that can be done by rearranging it. We can make y the subject. So first of all, make 3y the subject by adding it to both sides. 3y is equal to 4x minus 10. And then divide through by 3. I can just divide the 4 by the 3. You could write 4x over 3, but it's the same as 4 over 3 times x minus 10 over 3. And here the gradient is equal to 4 over 3. Now so to test whether two lines are perpendicular, their gradients are negative reciprocals of one another, or equivalently, they will multiply together to give minus 1. And that will indeed be the case here. I suppose maybe I should just show a bit of working to show how I get it. But yeah, I'm just timesing the fractions, and that is clearly going to give minus 12 over 12 or minus 1. You could say they're negative reciprocals, but I think it's quite good to just multiply them and get minus 1. So yes, the line is perpendicular to AB. Okay, and we're finished. Well done.